So like Carl said, this is all sponsored by the Pork Board. All the funding comes from them, so I'd like to thank them right off the bat. And really what we are talking about today is I went into the literature of everything that's published, and I'll get into kind of how I did that in a minute. And then we took out everything, all the performance data that we could get on alternatives, and just some other stuff out there, and try and put it all into one place, and that's going to be made available to you hopefully here this summer. All right, so we put a pretty good team together here from Iowa State and then the USDA also. And not only animal science, but we got some of the vets involved, got some microbiologists involved. So really a nice diverse team to kind of work on this together. I'm going to start by talking about what antibiotic growth promotants are. I'm going to refer to them a lot as AGPs. When I talk about it, I am talking specifically about sub-therapeutic antibiotics. I'm not talking about antibiotics for therapeutic use. We're not trying to replace those. Just trying to replace the antibiotics that are used for sub-therapeutic use to improve growth only. They've been used in the industry for more than 50 years. They're used for growth promotion and then the improvement of nutrient efficiency. And they can increase feed efficiency by 3%, growth rates 3 to 8%, and been very consistent in doing that. However, they've been around for over 50 years, but we still don't know how they work. We put them in the diet and they worked, and we just kind of left it alone. So now we're scrambling, trying to figure out how they work and then different alternatives that we can use that's going to replace how they work. There's two theories on how they work. There's direct effects and indirect effects, and this is going to be how do they influence the microbiota that's in the gut, and that's going to be an indirect effect. And then do they affect the host directly? Do they, is there better nutrient efficiency in the gut? Is there more bypass nutrients from the gut to the actual animal that they can use for lean tissue growth? That's kind of the two main thoughts right now. Again, it's still not totally known how that happens. And then the function and interaction of these AGPs on the host and the microbiota, like I said, are a lot less clear than we'd like them to be. So I'm sure as all of you know, January 1 of this year, the VFD, or the Veterinary Feed Directive, came into effect from the FDA. And it states that the production use of antibiotics in classes used in human medicines are injudicious. So it got rid of our ability to use antibiotics sub-therapeutically to improve growth or nutrient efficiency. We still can, however, we can use them for a just cause or judicious use. So if we want to treat animals that have diarrhea and things like that, we're not getting rid of that. But we do have to. They are under veterinary oversight now. We do need to get a script from the vets for that. So with all of this brought about, it really brings into focus now that we need to evaluate these AGP alternative products. And again, I can't harp on it enough. I'm talking about sub-therapeutic antibiotic use only. I'm not talking about therapeutic antibiotic use. That's the only thing we're trying to determine an alternative for at this time. So if you get on the internet and do a quick search of antibiotic alternatives in pigs, you're going to find thousands upon thousands of hits on the internet. So when we first started going into this, we found thousands of studies, and I'll show you how many thousands we found in a minute. But there's several different things that they looked at. They look at body weights, they look at feed intake, they look at this, that, and the other. But nobody really did the same thing across all those studies. And really that's what we're trying to get down to is what are the things that we need to measure, what are the things that would probably be good to measure, what are the things that might not necessarily need to measure, but we still can. So, when we went in and looked at if these studies worked or not, we wanted to figure out what made them work and why did they work. So was it the number of replications that they had, or was it the pen size that they had, or was it the base diet, how long did they feed this for, so on and so forth. That's what we really try to determine out of this. So really the main objectives here were to evaluate the literature to assess dietary alternatives to subtherapeutic antibiotics. And then once we found that out, we wanted to examine trends and relationships of the efficacy of these AGP alternatives to improve pig performance and reduce mortality. So we're really focusing on the performance and mortality aspect, not so much on everything else. So what we did is we identified the committee that I showed before, that we identified AGP alternatives that are currently used in the industry, and I'll show you those in a minute. And then we decided to keep everything from 1990 till the present. With the type of pig that we have today, the genetics we have today, we wanted to keep it somewhat current. The last time this was updated was in January of this year, so we've got everything through 2016. After we got all those papers, we looked through all the abstracts and said, do they mention performance, whether that be average daily gain, average daily feed intake, or feed efficiency? Do they mention that in the abstract? Or do they talk about mortality in the abstract? We determined that these papers had to be from peer-reviewed sources and that they had to be original research. So there was no review papers that were included in this. There were no conference proceedings that were included in this. It had to be strictly published research. It had to be in English. I don't speak any other languages, and I don't read any other languages. So there's a lot that we left on the table because of that, but that's my limitation that I have. And we were primarily interested in nursery trials. However, there are a lot of sow trials that that were published, and then there's some finisher trials too, so we didn't exclude those at all. We left those in. So we ran all of our search terms through these databases. These are very common databases that we use in the academic world. And then we searched all years initially, so we had everything from about 1900 until the present. So we really got a good body of data to start with. These are the categories that we determined were important: probiotic, prebiotic, oligosaccharide, organic acid, essential oils, botanicals, and plant extracts. We all bunched into one, and I'm going to refer to those as botanicals. Yeast, resistant starch, and dietary fiber we bunched together. Zinc and copper we bunched together, and then lysozymes. And then these are the search terms that go along with them. We did test it to see. We ran probiotic in swine. We did test it as probiotic in pig, and there was no difference in the search results. So we just kept it as swine, and that gets rid of all the guinea pig studies that might have turned up. So really, just a real simple breakdown of what we did. We took that search term, put it in the database. We moved all those results into another database that we could work with a lot easier. We removed the duplicates, keep everything that's original and peer-reviewed, and since 1990. And then we exclude all the articles that didn't contain performance or mortality, and then keep everything that's in English and that we could get our hands on as far as a full paper. So once we got all those papers, then the real work started. We had to read all those papers. And we determined that it was probably good to look at all of these parameters here. So we looked at, was there a health challenge, yes or no? What was the number per treatment, whether that be pig or pen? What was the experimental unit, whether that be pig or pen? How many pigs were in each pen? Age of the pig? How heavy were the pigs? What were the genetics? How long was the study? How long? What were the main dietary components? And then we looked at performance. So we looked at, did it decrease performance with a negative? Was there no difference with a 0? And then did it increase performance with a positive? And we determined that it had to be statistically significant for us to say, yes, it improved performance, or no, it did not. So basically that's saying everything is less than 0.05. So we determined that the variability that was seen in that study, 95% of it at least was explained by the dietary treatment. So that's kind of the cutoff that we made for ourselves. And then we looked at some of the lab assays that they might have done, whether it be blood or tissue, or if they evaluated the microbiome. And then probably in the last month or so, we decided it's probably good to look at, was there antibiotics included in the base diet, whether it be therapeutic or sub-therapeutic. We haven't gotten to that stage yet. It was just a simple yes or no. Was there antibiotics in that diet? And then also we looked at, is there specialty proteins in that diet? Just a simple yes or no. And specialty proteins, that'd be our soy isolates, that'd be our spray-dried plasma, some things of that nature. So one little note I would like to say, we have number of studies and then we have number of trials. And where we come up with the number of trials, within each paper there can be more than one trial. So if there was a control and multiple treatments, we consider each treatment as a trial. So in an example, if there's control and these 3 different acids that were fed, that paper would include 3 trials. After we got all of this data, we compiled it into an Excel spreadsheet, and from there we could work with it using pivot tables to determine any trends or patterns that were in each parameter. So here's kind of the meat and potatoes of it. The number of publications we started with was just shy of 24,000. After we got rid of duplicates in 1990, really when we started the work, there was about 14,000 papers. The ones that we determined usable that reported performance or mortality, we got down to about 1,300 articles that were in English that we could get our hands on. Ended up with 830. So even though there's a lot of research out there, what we deemed appropriate, there's not a whole lot out there. So from the 830 published studies, we had 2,019 total trials. And if we look at the antibiotic use in those trials, 24.5% of those studies did use antibiotic in the base diet. So you're comparing a treatment compared to an antibiotic. And 73% of those did not use a base diet, so you're comparing that to a true control pig. Some of the common antibiotics are used: Tylosin, CTC, Oxytet, Colistin, and Carbidox. So I'm going to go through this really quick, but we started with our search term. So in the case of direct-fed microbials or probiotic, we started with about 3,500 papers, whittled it down to 2,500. What contained performance and mortality, there was 314. What we could actually get our hands on, 189. And we've got all that data for each category that we determined was appropriate. So then from the 889 total articles, 311 total trials. Of that, 46 used the health challenge. And when we refer to health challenge, that includes LPS, E. coli, Salmonella. All of it was included if they left the nursery dirty, things of that nature. So then we can look at just a very crude overall of all these 311 trials. The average number per treatment was 21. Pigs per pen was 6. Average study duration, 37 days. 24-day-old pig and 14-kilogram pig. And then, when we start looking at trends within each of these, especially for probiotics and some of those that have classes within the probiotic class, we can say, well, 49 of these studies use a bacillus species. 27 of these use bifidobacterium, 37 enterococcus, 62 lactobacillus, and 87 use a combination. So that's really where we can get down to and say, what are the popular ones, what are the not popular ones, what works, what doesn't. And I'll get into that in a minute. A great lead-in for me. So I'm going to talk about potential modes of action here. I'm not going to harp on it a whole lot, but I really want to get into the efficacy or how well they work. So if we start with probiotics or direct-fed microbials, it's a live microbial feed supplement that can survive in the gut. So we're feeding a live bacteria that we're hopefully going to establish in this pig. There's 3 common categories. There's bacillus, there's lactic acid producing bacteria, so that'd be our lactobacillus, our bifidobacterium, and our enterococcus. And then there's yeast. The mode of action is not completely understood, and you'll see that's going to be a common theme throughout this paper because we've never really had to understand how they work, if they work, similar to the antibiotics. They're thought to inhibit pathogen adhesion. They can produce antimicrobial substances like organic acids that can also benefit the gut. And then they can outcompete those bad bacteria and modulate the host immune system to reduce the immune pressure that's in the gut. So there's going to be a lot of slides that look like this. In the top left is going to be percent outcomes average daily gain. Top right is going to be average daily feed intake. Bottom left is going to be feed efficiency. Bottom right is going to be mortality. And then in the yellow is going to be a positive outcome, or an improved average daily gain. In the red here is going to be a decreased average daily gain. In the gray, there's no change, and in the brown is not reported. So you can see for the 311 total studies, 40% of the time, those trials reported an increase in average daily gain. That's all we can do. That's the only scope of this review, is that it's the percent outcomes of this study. It is not, it improved by 40%. It's just 40% of these trials reported a positive outcome. We need a meta-analysis for that, and that's a lot more time than I have left in graduate school to do that. So 40% of the time, these probiotics improved average daily gain. Only 1.6% of the time, they did not. Now, recently we just broke this out and said, well, is it different when there's antibiotics in the base diet compared to no antibiotics in the base diet? So we can see here 38 trials used antibiotics in that base diet, and we reduced our efficiency here to 31.6% of those trials reporting a positive outcome. That compares to 41% when there is no antibiotic in that diet. So kind of interesting there. If there's antibiotics in the diet, we're less effective here of our probiotic. There's just a lot more that are no difference. And I'll touch on some reasons why that might be at the end. Yeah?
Sorry, real quick, can you repeat, is the 40% that showed a positive outcome, were those studies that showed a significant difference?
Yep, that's the only thing we're reporting on here. So this would be...
Your criteria.
Yep, they met the criteria, and then it was significantly improved or significantly decreased.
Got it.
Yep. So then feed intake, 13% reported a positive outcome compared to when there's antibiotics in the diet. This is going to be a common trend kind of throughout. There's antibiotics in the diet. Generally, it improves the feed intake. Is kind of what we've seen compared to when there's no antibiotic in the diet. We see it's not a whole lot different from the overall, but it's reduced compared to the antibiotics that are in the diet. And then feed efficiency, again, that's going to look a lot like our average daily gain. About 26% of the overall studies improved feed efficiency compared to 18% when there's antibiotic in the diet, and 26% or 27% almost when there's no antibiotic in the diet. I'm not going to spend a whole lot of time on mortality. I know it's important, but there's just so many studies that did not report it. So all I have here, there's going to be no brown bars because they'd be all about 80%, 70 to 80%. So again, about 5% of the time, there's going to be mortality improvement. And when I say mortality improvement, it's going to be reduced mortality. So about 5% of the time, we saw an improvement in mortality in these studies. So if we move on to yeast, again, about 23.5% of those 98 trials that we looked at improved or reported an improvement in average daily gain. A little bit less of a dramatic effect here in the antibiotic, where 22% of the trials reported a positive outcome, and then 25% when there's no antibiotic in the diet. And kind of by going by the mode of action, this makes a little bit of sense because we're trying to modulate that the antibiotics are going to inhibit a little bit. Again, we see when there's antibiotics in the feed, we get an increase in feed intake compared to when there's no antibiotic in the feed. But again, when we look at our feed efficiency, we don't lose any feed efficiency as far as outcomes from these studies. We see about 11% of the overall studies improve feed efficiency, 8% when there's antibiotic in the diet, and then 13% when there is no antibiotic in the diet. And mortality, 1% of the studies reported improvement, 1% of the studies reported no improvement or a reduction in mortality, or an increase in mortality. Sorry, and no antibiotic studies reported that or reported any difference. So again, within the scope of this, we can say, well, there's 124 trials that improved average daily gain, and then we can go in and say which ones were the most effective, or on average, which ones improved it more often. So 37 of those 124 trials were a combination of probiotics. Now within that combination, there was no difference. We couldn't discern a pattern within those combinations. 30 of those 124 trials used a lactobacillus species. And then 8 of those 30, so a fairly large quantity here, used Lactobacillus plantarum specifically. 20 of those trials used Bacillus, 17 used Enterococcus. Interestingly, 16 out of those 7 used Enterococcus faecium. So that's kind of the abilities that everybody's going to have here to use this database. You can go in and say, of the studies that improved, how many pigs are in the pen, or what probiotic did they use with the most efficacy, just some things like that. So if we move on to prebiotic, there's selectively fermented ingredients that change the microbiota to benefit the pig. There's several ingredients that act in this manner. I'm going to talk about oligosaccharides, and then, like I said, we lump together dietary fiber and resistant starch. Again, the mode of action, they selectively stimulate the growth of microbiota associated with a healthy gut. So this would be our bifidobacterium, our lactobacilli, our enterococcus. A lot of those that we're feeding as a probiotic. Instead, here we're just using an ingredient to try and bolster those populations in the gut compared to just feeding them directly. So we look at prebiotics first, just so we don't miss anything that might not come in the oligosaccharide or the resistant starch, so we can try and get as much numbers as we can. So we ended up with 99 overall trials in the prebiotic. 11% of those reported a positive outcome in average daily gain. Now this is where it really kind of hits home. When there's antibiotic in the diet, we only have 3%, 2.5% that are reporting a positive outcome of that prebiotic. But compared to when there's no antibiotic in the diet, we're almost up to 17% that report a positive outcome. Again, feed intake, when there's antibiotic in the diet, we see about a 10% of the studies report an increase compared to 3 when there's no antibiotic in the diet. And then again, this growth is reflected in the gain to feed. 9% of the overall trials, only 5% when there's antibiotic in the diet, compared to almost 12% when there is antibiotic in the diet. Oligosaccharides, kind of a similar story. 18.5% of the 92 overall trials reported an improvement in average daily gain. When there's antibiotics in that base diet, only 11%. When there's no antibiotics in that diet, 21% of those studies reported a positive outcome. Feed intake, 8.7% of the overalls. What's interesting here is there's no improvements in feed intake of the studies that had antibiotics in the base diet. However, that's not necessarily inherently bad if they can still grow on this reduced feed intake. So it's still not necessarily a bad thing. And then when there's no antibiotics in the diet, we see 10% of those studies reported an increase in feed intake. And again, we see that a number of studies reduce the feed intake, so we get a little bit of a wash here on our feed efficiency. About 21-22% of those studies, of all studies, are going to report a positive outcome for gain to feed. So we move on to starch and fiber. This one by far had the most negative outcomes. 8.9 of the 281 studies, 8.9% of the 281 studies reported a positive outcome of growth, while 15% reported a negative or a reduction in growth. When there's antibiotic in the diet, what we see is there's no studies that reported an improvement in growth. So that resistant starch or that dietary fiber is probably not being allowed to do what it's supposed to do to improve that growth when there's antibiotic in the diet. And we still see about 15% of those studies reporting a decrease in performance. Compared to when there's no antibiotic in the diet, about 10% of those studies are reporting a positive outcome. When we move to feed intake, about 8% of the overall studies reported a positive or an improvement in feed intake. Only about 4% when there's antibiotic in the diet, and 8% when there's no antibiotic in the diet. And then feed efficiency is going to look very similar to the growth. About 7% report a positive outcome when they're just in the overall, 4% in the antibiotic, and then 6.5% in the no antibiotic. Move on to botanicals. Again, we lumped in essential oils. We lumped in plant extracts. So these are plant-derived products. They're herbs and spices, essential oils, and oleoresins. And the mode of action, again, not fully understood. But there's antioxidant potential with herbs and spices. There's antimicrobial actions from essential oils, from herbs and spices. And then one thing, too, is it improves the flavor, and it can improve the palatability to increase feed intake when we feed some of these different ingredients. So this was the second largest category, 365 total trials. 23% of those reported a positive outcome in average daily gain. Again, when we have antibiotic in the diet, we see that number reduced by about half to 10%. When there's no antibiotic in the diet, we see even a little bit of a bump to 24.5% of those trials reporting a positive outcome. Feed intake, looking a little bit opposite of what we've seen so far. 9% of the overall trials reported a positive outcome. When there's antibiotics, we only see 3.5% of those reporting a positive outcome, compared to almost 10% when there's no antibiotic in the diet. Feed efficiency, again, that reflects the growth. We see reductions in the number that reported positive outcomes with antibiotic in the diet. We see here that when there's antibiotics in the diet, no studies reported a positive outcome for feed efficiency. While when there was no antibiotic in the diet, we see an 18% increase, or an 18% of the studies reported a positive outcome. Organic acids, these are weak acids and they're salts, and they reduce the pH of the feed and water. So these are a little bit different from everything else. We can put them in the feed, which has been common for the previous ingredients, but we can also put these in the water, so a little bit more of an immediate impact. Some common acids that are fed or in the water are citric acid, formic acid, fumaric acid, lactic acid. These are all common in the industry. Modes of action, these are a little bit better understood. There's antimicrobial activity that comes with feeding these organic acids. It can lower the stomach pH, which is going to increase our digestion and specifically increase our protein digestion. It can also provide an energy source for the gut. So I didn't mention butyrate here, but butyrate is an important energy source in the large intestine especially. So we can definitely get some energy sources out of feeding these organic acids. 151 overall trials, almost 32% of those reported a positive outcome in growth. Again, a little bit surprising to me anyway, when there's antibiotics in that diet, only 11% of those studies reported a positive outcome, compared to 35.5% when there's no antibiotic in that diet. Feed intake, kind of similar to what we saw in the oligosaccharides, 13% reporting an overall positive outcome, only 5.6% when there is antibiotic in the diet, 15% when there's no antibiotic in the diet. Feed efficiency, again, looks very similar to the average daily gain. 18% of those studies reported a positive outcome in feed efficiency. When there's antibiotic in the diet, only 5.5%. When there's no antibiotic in the diet, we bumped that up to almost 21%. This one was the most reported on and also the most effective in reducing mortality. 6.6% of those studies overall reduced mortality. We see that increased when there's no antibiotic in the diet. Zinc and copper, these are essential trace minerals. Zinc, they are recommended in the diet, so they're in your diet already. because we need, they're essential trace minerals, we need them in there. So when we talk about zinc and copper, we're talking about pharmacological doses of zinc and copper. So it's recommended by the NRC 100 parts per million in your diet. Pharmacological levels, we can get up to 3,000. Exact mode of action, again, not necessarily known. It reduces and can prevent post-weaning diarrhea. It can increase antimicrobial peptides in the small intestine, and then it can reduce gram-positive bacteria in that gut. So this was one of the most effective and by far the largest, 613 trials. Almost 39% of those reported a positive outcome in average daily gain. This one was probably the least affected, or one of the least affected when there's antibiotic in the diet compared to when there's not antibiotic in the diet. So 37.5% when there is antibiotic, 41.5% when there is not antibiotic in the diet. Feed intake, not a whole lot different, 24% kind of across the board, 26% when there is antibiotic in the diet. And then feed efficiency, not quite as drastically affected as some of these other ones. 20% of the overall trials reported a positive outcome in feed efficiency, 15% when there's antibiotic in the diet versus 25% when there's not. Again, we see a little bit of a mortality reduction in mortality here, about 1.8% of those overall trials. So again, some of the other ingredients I talked about with the DFMs or the probiotics, but a lot of those other ones, there's no discernible pattern that we could find of a specific acid or a specific resistant starch or anything like that that was reducing or that was improving performance. But in the zinc and copper, of the 243 trials that improved average daily gain, 73 of those 243 used copper only. 13 of those used 125 parts per million. Another 13 used 200 parts per million, and 15 of those used 250 parts per million. And then 154 of those 243, 27 of them used 3,000 parts per million of zinc. 17 used 2,500 parts per million, and then 11 used 1,500 parts per million. And then there were a few, about 12 of them, that reported a combination of zinc and copper. 4 reported 3,000 of zinc, 100 of copper. 4 more reported 3,000 of zinc, 250 copper. And then 2 reported 3,000 of zinc, 125 of copper. So this is the last specific ingredient I'll talk about. I know it's getting a little repetitive, but lysozymes are a naturally occurring enzyme found in bodily secretions. So these are found in your tears, in saliva, in milk. And this enzyme functions by attacking the cell wall of the bacteria. Attacks the peptidoglycans in the cell wall. This is especially effective against gram-positive bacteria. This can also enhance mucosal immunity and the immune response from the pig. Now, what first jumps out at you is, wow, 44% of these lysozyme trials reported a positive outcome. Well, I want you to remember those. There's only 9 trials that used the lysozyme and that reported or that met our criteria. So these numbers may be a little bit inflated, but still seems to be somewhat effective. When there's antibiotic in the diet, again, there's only an N of 1 here, so don't put a whole lot of weight on that, but there's some potential there that it should be explored a little bit further. And then again, when there's no antibiotic in the diet, 57% of those trials reported a positive outcome for growth. Again, feed intake, very similar, about 10% increase in the overall, 14% of those coming from the antibiotic, no antibiotic in the base diet. Then about a third of the lysozyme trials reported an increase in feed efficiency. And then there was no mortality data reported in these trials, which is interesting because on the overall, these were in a lot younger pigs, so you'd expect them to maybe report mortality, but that was not the case. So if we look at all of them together and we say, well, let's just take antibiotic alternatives as a whole, how effective are they? Of the 2019 trials that we looked at, about 28% of them reported an increase in average daily gain. When we look at if there's antibiotic in the diet, 27.5%. When there's not antibiotic in the diet, 29.2% reported a positive outcome. Feed intake, again, a little bit similar to some of the other ones. 14% of the overall trials reported a positive outcome. 19.5%, almost 20% when there is antibiotic in the diet. 13% when there's no antibiotic in the diet. Feed efficiency, again, very similar to kind of what we've seen. 17% of the overall. 12% when there is antibiotics in the diet. 19% of those studies reported an improvement when there is no antibiotic in the diet. And then overall, 2.3% of those studies reported an improvement in mortality. So we decided that Well, let's look at it without zinc. Zinc is kind of a proven commodity a little bit compared to some of these other ingredients that we're testing. So what if we take out zinc? Is this picture going to change any? And the answer is yes, it does. We're down to only 1,400 studies now, but we see that reduced from 28% to 24% of the studies reported an increase in average daily gain. But what's interesting here is now when there's an antibiotic in the diet, instead of being 27%, it knocks it in half to 13.5% of those trials reporting a positive outcome. When there's no antibiotic in the diet, that number doubles to 26% of those trials reporting a positive outcome. Feed intake, we don't see a whole lot of difference, about 10% of those trials reporting an increase in feed intake. Feed efficiency, though, again, very similar story to the average daily gain. 16% of those overall trials reported an increase in feed efficiency. 9% of those when there's antibiotic in the diet, compared to almost 18% when there's no antibiotic in the diet. And then 2.5% of the trials reported an improvement in mortality. So I haven't talked a whole lot about specialty proteins. I mentioned that we went through and just said yes, no, and we really finished it up kind of beginning of this week. So there's a few more bars here, but SP, specialty protein, positive is there is specialty protein, negative is there is not specialty protein. So we have specialty proteins by itself, and then we have all the antibiotic combinations that go along with that. So we can really break it down and say, is there something in here that would make us want to use an antibiotic or not use an antibiotic with that specialty protein. So overall, in average daily gain with specialty protein, we saw 31.4% of those reported an improvement in average daily gain, compared to only 26.5%, almost 27% when there's no specialty protein in the diet. And again, specialty proteins, that's going to be our soy isolates, that's going to be our spray-dried plasma, things of that nature. Feed efficiency, or not feed efficiency, feed intake, 19% of the overall studies that used specialty protein reported an improvement in feed intake, compared to only 10%, 11% when there's no specialty protein in that diet. Feed efficiency, not a whole lot of difference, 18% versus 16.5%. So a couple additional uses that we have for this. This is going to be a little bit more on the research side or some things of that nature. So we can go into each category and say, well, what's kind of the parameters, or what are the pigs kind of looking like when there's no response, when there's a negative response or a positive response. And what's interesting is in some of these ingredients, some trends really jump out. So when there's a negative response, granted there's only 5 studies, the start body weight's almost 26 kilograms, and they're only fed 28 days, so they're 44 days old roughly. When we get a positive response, they're about half as big as the pigs that showed a negative response, and they're fed almost twice as long. So some trends like that kind of jump out. So from the research side, or even from the production side, I say, well, if I'm feeding the DFM and I only feed it for 27 days, I might not actually get any benefit in performance. Maybe I need to feed it closer to 45 days. And then again, a little bit more on the research side, we can get numbers per treatment. So if I want a positive outcome, I should probably be in the 6 to 18. I know that's a big range, but I should probably be kind of around that 6 per treatment, and then pigs per pen kind of in that 6 to 7 range. And then if we look at just the overall, 574 studies reported a positive outcome. Pig average body weight was 10 kilograms, fed for 38 days. And then N per treatment, 6 for the median, average of 12 to 13. Pigs per pen, 5, average of 7. So somewhere in that 5 to 7 range is where we're seeing the most benefit. And that really makes itself known here when we've got the number of trials. We've got 1 pig per pen, 2, 3 to 9, 10 to 12, 13 to 20, 21 plus. And really, this makes a little bit of sense in that 3 to 9 range. A lot of the published studies that are out there are done in an academic setting. Not a lot of universities have the capability to go 21 pigs per pen. So a lot of them are in that kind of 5 to 6 range. So that's kind of what we expect to see that number so high in the positive outcomes for average daily gain. And this is overall studies. So just final concluding thoughts here. About 30% of the AGP alternatives improve growth performance. The most efficient of those, and these are overall numbers, the most efficient of those are DFMs, zinc and copper, and organic acids. And the efficacy of these antibiotic alternatives, when we feed an antibiotic in the base diet, we see a lot of those reduced. And with where the industry's at now, we should probably be focusing a lot more on that no antibiotics in the base diet to see how much they improve compared to when there is antibiotics in the diet. Like I touched on a little bit, antibiotics can alter the gut microbe profile and the populations in the gut. So a lot of the the things like probiotics and prebiotics that we're trying to feed to alter that gut, while antibiotic is also doing that. So then it's a little bit of competition between the antibiotic and then the alternative also. So this database is an effective tool to predict trends on pen size, on pig age, on weight, on feed duration, to evaluate these different alternative products. And this is going to allow us to develop a protocol that defines critical and essential components that can be used in these studies. So if there's a takeaway, this project will recommend necessary parameters that should be recorded and when they should be recorded. Recommendations on project design that best translate from smaller scaled research to industry, like numbers per pen, pigs per pen, anything like that. And it'll also help us determine what are useful parameters, and on the flip side, what are not useful parameters to measure that may relate to the altered pig performance and mortality. And this project will not recommend best alternatives to use. I think it's very system dependent. It will also not recommend a certain genetic background or health status to best evaluate on. So this is just a review of the literature. We don't have any numbers to say it improved by this much or that much. This is only just a look at, yes, it improved it, or no, it did not. With that, I'd like to thank the Pork Board again. I'd like to thank everybody from Iowa State that helped out, everybody from the USDA, and then everybody from our lab that helped out. And with that, I will take any questions.